Okay, so good afternoon once again. So welcome to week 2 of our beginner Flutter training in KodeCamp 4.0. Yeah, my name is Gage Kwachom, as you all know. So today we are going to be talking about functions. In the last class, we were able to, talk about, control structure, right? And we did some, some work on it, some hands-on, and we're able to build a number guessing game and all those, right? So, but today we're going to be going into functions. So, just going to create a new folder here. I'll call that week 2. So, functions dot dart. Okay. Sorry, functions dot dart. Okay. Okay, so let's start. Can anybody help me? What's a function to you? Can anybody help me? What do you understand by the word function, right? Maybe not from a programming perspective or whatever, however it comes to your head. Can anybody tell me what they understand by function? Anybody? Anybody? Remember, I like communications in my class, right? So let's remember that. Dele, what's a function, Dele? Let me call that since you guys want to raise your hand. So what's a function to you?
A function is a set of declarative or a step, a, a collection of steps that determines how something is being achieved or done.
Okay, that works. Okay. David, how about you? David, yeah. Ohimai. Okay, let me not try to pronounce that. So how about
Okay,
you?
I'm
What's a
looking for it.
function?
Okay, a function is an expression of variables, yes, that
An ex
carries out a task.
an expression of what? Variables.
Yes,
Oh wow, okay. That's it. That's the first time I'm hearing such a definition. Okay, that's fine. That's fine. Okay, so let's run. Trying to see if I can cover much today, right? So basically a function, let me start by saying this. Functions are not strictly necessary when it comes to writing programs, right? Besides, we have been able to write one or two stuff and run stuff here in our week 1. We did not necessarily have to write a function to actually carry out this whole guessing stuff, right? Okay, other than this main function, which I'll talk about. So I've not really created any function, and the main function is an entry point. Okay, we have not actually created our own function, right? Now, in as much as they're not strictly necessary, right, they are certainly very, very important if you want to keep if you want to keep your sanity when you're writing a complex program or a complex application. So functions allow a program to be broken down into what I call callable units, right? Basically, a callable unit is just like it's just a portion of code that can be executed. Okay, so think of it. I like to use this example. Think of it for some of you who will probably have or you already have a maid, right? You employed a maid to carry out a function. You employed your driver. The driver has a function. Now, when you want the driver to carry out his function, what do? You call the driver by name. So when you call the driver by name, right, it means that you want the driver to carry out its what function. Okay, so if you want somebody to drive you, you won't start shouting, drive me, drive me. No, no, no. You have to call the name of the driver because that's how you identify that driver in order for you to carry out that what function. Okay, so function allows a program to be broken down into callable units, and a callable unit is just a portion of code that can be executed. Now, the interesting thing is that, for example, you may have a function that makes your computer to beep, right? To give a sound to beep. Now, if you want to actually name that function, what will you name it? You name it beep logically, right? So the naming of a function should reflect on what the function actually what does. Okay. Now, another thing is you may want the computer to probably beep when in two scenarios. Scenario one, when the user probably types a wrong hits the wrong key, or when the user gets a message, you want to have a beep. So this just shows that you can actually call a function from different places. And basically what that does is that it saves you time of writing. You won't have to rewrite the logic. Imagine if you have about 20 lines of code to make your computer beep, okay? And you want your computer to beep in 10 scenarios. You don't have to write 20 lines of code in 10 places. You just need to write it once. You need to create a portion, a function that does that, and then you're able to call it in different places, right? So what does a function look like? So let's just come to our functions file. Now, you've seen this already, so I'm just going to kind of write it normally. Let me change my inputs. Okay. So I have this. Now, this is an example of what a function actually looks like. You've seen this before. This is the main function. So the first part is actually the title, right? Or the name of the function. The title of the function or the name of the function. So in this case, it's called main. Now, after that, we now have what to call, this is not brackets. Now, it's called a parenthesis, right? Parentheses, parenthesis, right? And you can, if you look at this, it's actually empty, right? Now, we'll talk about parameters, right? But you can actually have something inside called parameters, which are basically more like, think of them as requirements for a function to, accomplish its task. For example, for a driver to be able to drive you, one of the major requirements that you need to have the key, right? You need to have the key. So if you have a driver, his function, the reason you employed him is to drive. But if he doesn't have key, if he doesn't have the key to the car, he's not going to be able to drive because he's not going to push you inside the car. So that's basically what kind of what parameters are, right? So they are more like requirements for a particular function to execute. And then we have what we call a curly brace, right? This is basically it. If I just delete this out. So we have a curly brace. Now, inside of this curly brace, that's where we now have the actual code that will be executed, the set of instructions that will be executed to carry out when the function is being called. So we're going to do some hypothetical stuff, right? Let's say I talked about a beep function, right? So from the name, beep, right? It basically so like I said, when you're naming a function, you kind of should name it, it should reflect what the what the function actually does. Okay, you should reflect what the function does. So when I create this function, let's say beep, right? And all I want this function to do for now is just print something to the screen. So print beep. Now, I have created this function. So think of me creating this function, right? Think of me creating this function as me hiring a driver, right? I just hired a driver. So now I have this function that can do this, meaning I have a driver that can drive me. But just creating a function doesn't mean you have done anything, right? To actually make use of that function, you have to call the function. So calling the function, when you place a call to the function, you're basically now telling the function, hey, come over and execute the instructions that have been given to you. So when you call your driver, hey, okay, let me not use any name so that's the same. Hey, driver, right? Okay, take me to so and so. So the first thing is calling. So how do you call a function, right? Basically, just the way you would call somebody. You call it by its name. So if I want this function to do something, I have to call it by its name by just saying beep. That's all. So that is how you call a function. So by calling this function, it will now perform whatever task that you actually wanted it to what perform, which you can see print what beep, because what I have now called it. So the moment I placed a call to this function, every instruction inside of this curly brace will be what's executed. Okay, so that's one. Now let's talk about function parameters. Okay, I hinted about it, but let's talk about function parameters. Now, this function we created does not have any parameter. There's nothing inside here. It does not require anything to actually run. All you just need to do is call it. It will just what take action. It doesn't need any extra information, right? So functions may not have parameters, right? But we can also have a function that has that takes a parameter. That means it needs an extra information for it to actually work. Now, in this case, I could now create a function. This is creating a function without parameter. Okay, so I don't need to. Don't worry. I wanted to do something, but I don't need to. It's not like you're writing or taking notes, but you're just following up. Now, if I want to create a function with a parameter, I just need to now say, okay, fine. I'm going to give this function a parameter. Now, this is a beep function. I want to give it a parameter of, let's say, I'll just say seconds. Now, what does this mean? I'm passing a parameter, right, which is like an extra information, a prerequisite, a requirement for this function to run. And that requirement is this variable called seconds, meaning I'm saying that, look, if you're calling this function, that means you want it to print beep. But how many times do you want it to beep? Do you want beep, beep, beep 3 times? Do you want 5 times? Beep, 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 beep. How many times? How long, rather, do you want it to actually beep? So that is a parameter. That's an extra information, right? So when we call this function, you can see here in this function call, it says 1 positional argument expected by beep, but 0 found. Try adding the missing argument. So the word argument, parameters, we'll use them interchangeably, right? They kind of mean the same thing. So you can see that it is expected. So think of it this way. You've called your driver. Driver, come. He comes. Take me to, or you just take me to Chicken Republic. And you'll be like, okay. He's looking at you, you're looking at him. What he needs an extra information. So he could probably ask you, okay, sir, the key, that in case he doesn't have it, right? Maybe he's not, you just employed him, so you don't want to just trust him with the key. So immediately he's done, just give it to me, right? So of course, the next thing, he requires that key. So it's not enough to call him. You need to call him and give him the requirements, give him the extra information. The extra information, for example, could maybe not just be the key. It could be the direction. Direction could be the extra information. Where are we heading to? It's not enough to tell me to drive you. Where am I going to? You understand? Another extra information could be, am I dropping you off and waiting, or am I dropping you off and coming back? So these are just extra information that the driver actually needs to perform his task effectively. So that's basically what function parameters. So when we call beep here now, we need to pass in the number of seconds we want, the beep sound to be made, right? So that's basically that. So I could say, okay, fine, 20 seconds. You can see the error goes away. So what am I saying? It should print this for 20 seconds. We're not trying to write actual code here, but I'm just explaining what functions are. We'll actually do some stuff, right? So another thing I could also, just to show you, I could have a function that's called say hello. Now, how can we use this? Let's say I just have, and this is what I want. I want it to print, let's say hello. So let's give it a parameter. So say hello, right? Now, as in this function, now basically what we're trying to do, we're just trying to print a message that says hello. But it would be nice to be able to say hello, so and so, like someone's name, right? So let's now pass this as a parameter. So if I put it here, say hello, hello Dele, right? And I just call hello here. I could say hello. right? So it will give me hello daily when I run this, right? But what if I don't want it to be, I don't want it to just be daily. I want to be able to just put any name, pass in a name as an argument, right? So that it can change. It can be daily, it can be anyone, right? So whenever I want to say hello, you need the information you need is the person's name. Okay, if you go to you meet some set of persons, right, in a group. If you don't know someone, what do you do first? You try to exchange, okay, my name is this, my name is that. Oh, hello this, hello that. So imagine hello, imagine you're with a bunch of people and you're just saying hello, 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 hello. All of you are just hello and hello. Nobody knows each other's name, right? So I want to curb that. So what I'll just do is, okay, fine, I want to be able to take in a name as an argument, and a name is a string, right? So I'll just say string name. So instead of saying hello daily, I'll now say hello name. But remember, I have to make this I have to put the $sign, so I reach this as a variable. So you can see now it needs an argument, it needs something. And what it actually needs, you can see, is what it needs: an argument here. And it's of type string. So I have to pass in a string. So I could now say daily. So when I run this, we should still have hello daily. I can change this here. So I don't have to come inside this function. I'll just, at this call, I could just say, who is here? Hello, David, right? And then run this and it gives me hello, David, right? So this is what a function that takes what a parameter. Now, let me talk about something also that is important, right? And I'm going to take us to variables a bit, but we'll talk about the locality of variables. Now, this is important because function parameters become variables within a function, right? Function parameters, they become variable within a function. So this is a function parameter name, right? It becomes a variable within a what function. Okay, so variables within a function, they are called local what variables. Okay, they are called what local variables, and local variables have a scope that is limited to the block of code within which they are defined. What that means is this: look, this name is just exists here. This particular variable just exists here. It doesn't exist in this function. It does not exist inside this main function. It only exists in this what function. So that means it is a local what variable. Okay. Now, let's try something. Assuming I had this in this function, right? Let's say I create a variable called string. Let me just say string. In fact, let me remove this now. Okay. And then I'll say string name called daily. So I'm storing this here. Now, I cannot come to this place and say print name. Now you can see it says undefined. I can't go to the main function and call this guy because this is a local variable. It exists only within the scope of this what function. So it is a local variable. Okay, so it cannot be accessed outside of this function. So that's one thing we need to note, right? That's why I wanted to talk about the locality of variables. So variables can also, can be local to the block of code that within what functions. Now, a variable may be local to, for example, we could have a for loop, right? We could have a for loop, and a variable can be local to a for loop also. It's not necessarily just a function. So this is an example. Let's write some actual stuff. But I'm going to do this one in the main function so you see what I mean. So let's say I just have a for loop, right? Of course, I've done this. So I'll just say int I equals 0. Now I less than 10. Remember, these are the conditions, and then let's increment I. So for this given expression, I want to do something. So let me create I'm going to say bool, let's say dog equals, and we assign true to it. I just created a variable called what dog, and it has a value of what true. Now I can say if dog what does this mean? Remember, in our if conditional statement, this whatever is here has to be what true for whatever for whatever is inside this thing to work, right? So if dog, remember dog, the value of dog is true. So if dog, I can say int I want to create another variable int how many? Let's say 40. I've created another variable called how many. Now, let me come out here and try to use it, right? If I now try to say if how many equals to 40, in as much as it's a variable, I can't, we are still in this for loop, right? We are still in this for loop, but I can't even access this one because this variable was created in this scope, the scope of this if what statement, right? In this scope, remember when I talk about scope, where your the curly brace starts and where it ends, right? So this particular scope, this is also a scope. The whole of this is also a scope, right? This is also a scope, right? But in this particular scope, right, that's where this variable is defined. That's why I can see here. It says the value of the local variable isn't what's used. We try to call it here, but it's undefined, right? Because it only exists here. And if I take this out, you can see that it doesn't even this guy, this other one exists inside this forward loop. Okay, but and if I say I want to call dog, it can access dog. Why? Because dog was declared in a scope where this guy also exists, right? So let me undo that. So you can see this doesn't actually work. We can't print it, right? Now, dog was now defined inside the for loop, right? So outside this for loop, I cannot say if dog, because dog doesn't exist, is not visible, right? Because remember, if you check this, right? The interesting thing is that you can close out all these scopes, right? I could close this out here, right? But so if you check, the whole of this is inside of this for loop, even the declaration of this word dog, right? But this particular one is inside the main function, the scope of the main function. And dog was not declared in the main function. It was declared in this forward loop. So that's just the concept of what local variables. Okay. Now, but variables can also be declared outside of functions. So in that case, where they are no longer local variables, right? They're actually now, okay, use the word global variables, right? So it is actually now going to be like top level. So for example, let me just take this out. I could have, let's say, string name. Let's still use Dele. I think he was the first person to join the class. So I could now create a function that said called say hello. And what I'm going to pass in so let's say string name one. I'm going to create let's say name one, right? And all I want to do is print hello name one. So you can see I have access to what this name, not even this one. I have access to this because it is what global, right? It is created, it is what global is like top level. It's at the top level, but that's not what I want to call. Yeah. So let's let me take out this function from the main function, right? And let's say I have it here. Okay. So what can I do? I can just say, okay, I could just call say hello. It needs me to pass in what's it called? A string, right? I could pass in this name here. And we're good to go. So I have access to it, right? I have access to it. So that's basically just what's it called? The concept of global variables and local variables, right? So I could decide to just say, okay, fine, I want to print what's it called? So let's say Oh, well, it's still the same thing. So yeah, so that's just basically that on the locality of variables, right? So now we talked about we are looking at functions that take a parameter. Now functions can actually take multiple parameters, right? More than one parameter. So let's go back to our beep function. Now before we kind of like had something like say seconds, right? So let's assume I want to now part of the information needed for the beep function is the sound name. Let's say sound name, right? So this is a function that takes more than one what parameters. It takes multiple parameters, right? So I could just say, okay, let's okay, so let's do a sample of that. Let me keep this. Let's say I have this let me do something. Let's say I have this. I want to check the number of prints and let me just give it 0, right? Now I think I can create this later. So now I want to create a function called print many that takes a string, sorry, print. So what it does is that it takes a string, and then I'm going to use a for loop. I'll just say for I, rather int I, which could be anything. The I there is just a way to iterate through a list or a range. So if I is less than number of prints, you can see I have access to number of prints because it's actually top level declaration. And then we increment I. So what do we want to do? I just want to print for printing. Now I have this function, okay? So I can now do something. I can say, okay, in my main function, I can now reassign and say, okay, let number of prints be 10, right? Okay, let number of prints be what? 10. And I can only do this because this is not a constant variable, right? So and then I can now call my print many function. And what does it need? It basically just needs a string, right? That's just what it needs. So I can just say I will not come late to class again. Okay, so let's run this and then let's see what we have. So this is just what it gives us, right? It just, so for int I equals to this, if I is less than, as long as I is less than the number of prints, print this. This is just a placeholder. So the number of prints we now said should be what? 10. So that means it will print what? This stuff 10 times. That means the first time I is equals to 0, is I less than I, which is 0, right? Is it less than 10, which we defined here? Yes. Okay. It will print it once and then increment. I now becomes 1. Is 1 less than 10? Yes. It will print, increase 1 to 2. It will keep on going like that till, that's why you have this number of what print results. Okay. So but we could update this function. Instead of having this number of prints here, this function can now have its number of prints variable here, right? I can now decide to have it what? Here. Okay, that means I don't necessarily need this. I don't also need this. So what do I just need to do? This now takes 2 parameters. What needs to be printed and then the number of times it should be printed. So all I need to do after pass, the first one requires a string. That's why you see this is a string. The next one requires an integer. So I'm going to say 10. And then when we run that, we should still have the same results, which is this. So this is a function that takes more than one parameter, right? Now, the next part is if there are functions that return values. So think of function as return values as when you send, let's say you have, for example, you have a maid, right? Maid has a lot of things that they do or whatever, right? There are certain times, there's a certain function, there's a certain thing he or she, right? The maid has to what execute that requires the maid to give a feedback, right? To bring back. So you could send the driver, okay, take this card, right? Maybe part of the job of the driver, part of the function of the driver, apart from driving, is to run errands. So running of an errand is a function, right? Now, because the nature of that function requires that for every errand he or she runs, there has to be a return value. So the errand could be go and get me chicken and chips. You have to come back. You have the driver has ran that function. He has gone, taken the money, done what he needs to do. He's now back. He now needs to return. He needs to give feedback. Okay. So there are functions that return values. Okay. So let's see how we can look into functions that return value. A typical example is let's say I create a function called multiply, right? I just want to multiply two numbers, right? So I'm going to create a function. I'm going to call it. Now, to create a function that returns value, right? What you do is you decide the type that should be returned. Are you expecting an integer? Are you expecting a string or whatever? Or are you expecting nothing? Now, if you remember, if you've seen our main function before, you see something like this. This is how it used to be. This is void. Void is also a return type, but when you declare a function as void, it actually means it doesn't return anything, right? It doesn't return anything. Now, I have a function, let's say, called multiply, and it takes two parameters. Let's say int num1, int num2, right? Now, I want this function to be able to return something. Before, we were writing the functions and it was just printing out. But now, just return it so that I can do whatever I want with it. So what do? We now decide what type do we want to return. Of course, logically, right? You're dealing with integers, so you should expect an integer. So what we'll do, I'll just say int multiply. Okay, so I have defined a function or created a function that returns an integer value. Right now, you can see here it says the body might complete normally, causing null to be returned, right? But the return type is int. So we'll talk about null, but I think I hinted at it the last time because we're not doing anything here. So you're not doing anything, so nothing may be returned. That's why it's saying here that it might complete normally, but and cause null to return. But the return type is int. It is expecting an integer return type. So it says try adding either a return or a true statement at the end. So let's do something. So first of all, let's get the product of these two numbers, or whatever the user is going to put, so which is basically num1 multiplied by num2, right? That will give you, so after multiplying, we store it here. So what do? The next is to now use the keyword called return. And what do you want to return? We want to return the word product. We want to return the product. And that is it. So this is a function that returns something. So after it's done multiplying, right, it stores the result in this product and then returns the product value to you. It doesn't print it out. It returns it to you for you to do whatever you want with it, right? So now, because it is a return value, right? If I just say multiply and then I say 4 and then 3 or 2. Now, this is fine. But when I run this, okay, you notice that nothing shows here. There's nothing that is printed. Why? Because there's no part of this function where we said it should print anything to the console. What we just said is return. So it means that when this function is called, it's what returns something, but we need to be able to see what was returned. And how we do that is I can decide to put this in a print statement. Now, if I put this in a print statement, what am I doing? I'm getting whatever is returned and I'm printing it at once. That's what I'm just doing here. Because it's returning something, now that I'm using a print, the function of print is to display, print an object to the console, right? Another way is, okay, I could decide that let me store what is being printed in a variable. And then I can now print the variable. In fact, I can just play around with it, right? I have the return value. I can do whatever I want. I could decide to, say something like 4 multiplied by 2 is, and then I'll just put the function here. This also, like, it's just okay, so instead of this, I'll just say result. Since we have stored it, I'll just call results. Result. Yeah. So when I run this, we should still have the same thing. Okay, so I think that's clear. So now we have 4 multiplied by 2 is what? 8. The result here is what? 8. Okay, so it's pretty straightforward, right? So that's basically function that returns values, right? You can do anything. You can do the one that returns a string, a boolean and all those and whatever, right? It's all that's something you're going to play with, right? But let me introduce you to a few other things, like what we call a single line function. I could convert now. You remember when we did this function, say hello, right? We did something like this. And then we now said, okay, print hello name, right? Yeah, so this is fine. But a lot of times, whenever your function is just has only one line of one executable code inside, you can just use a single line function. Now, Dart has what we call a syntactic sugar that makes it possible to declare short functions. And that syntax is this. It's a combination of your equal assignment operator and your greater than, right? So you have something like, so instead of this whole parentheses this block, we'll just do this, right? And then I'll now say print hello name. So yes, so that has this, right? And it's used for separating the return type, the name, and parameters of a single line function from its implementation. So let me just copy this and then undo, but down to good, and then just put this here. Now, so you can see that we use it to separate the return type, right? The name, the return type, the name, and then the parameters of a single line function. Now, this particular function doesn't return anything, right? Now, what about this int multiply? What about this one? Okay, I could convert this to an inline function. So instead of even doing I could just do something like this. I could just say int multiply, right? And then I'll just pass in my int num1, int num2, right? And then I use this, sorry. And then I'll just do something like this. num1, num2. Right? So this is actually what the same thing, right? So just think of this as return. Think of this now as return num1 times what? Num2. So this is why we don't even need to of course, remember, I can decide to take out this and just say return num1 times num2 instead of storing it in the variable. I can just return it directly, right? So this is an inline function, right? In case you know so let's run it to be sure. Let's see if we'll still have 4 multiplied by 2 is 8. If I run this, yeah, so we still have 4 multiplied by 2 is what? 8. So that's what an inline what function. So let's look at an example that I have. I think this class was meant to actually be a short one, right? I have a much more interesting stuff for you guys next week. Sorry, on Thursday to be precise. So let's look at this game. How many of you, just quickly, you can either on the chat or your mute, how many of you have heard of rock, paper, scissors? How many of you have heard about it? I remember I said I was going to tell you guys about something today. How many of you have heard about it? Rock, paper, scissors. Who on this call has heard about it? Anybody? Okay, David has, just David. Wow. Well, the rest, what movies do you watch? Eh? Okay, Shonibari has heard. Okay, okay. Dele, Iman, okay, good. Now, can any of you just unmute and explain it to us? Does anybody know? Okay, drop your hand, right? Who here can actually explain rock,
Yeah,
paper, scissors?
I
Okay,
can. I can.
okay,
There
okay,
are
Dele,
there
go
are
ahead.
three there are three of the items or object: rock, paper, or scissors. For
Okay,
rock and paper, when you are playing, you can either play either a rock or a paper or a scissors. Now, a paper, if you play a paper and a rock, a paper wins because a paper can circle a rock. Then if you play a rock and a scissors, a rock wins because a rock can destroy a scissors. If you play a paper and a scissors win because a scissors can destroy a paper. So those are the rules.
good, good, good. So, um, okay, so let's go ahead. So let's use our this our understanding of what we have learned so far. Let's see if we can bring it into this game. Now we have the rock paper scissors. It's actually a very old schoolyard game, right? And it's actually used for quick decision making. For some of you have seen it on social media. People use it to play games and trend and blah blah blah. So in the usual setup, there are 2 players. Now, after we chant rock, paper, scissors, shoot, both players show a hand gesture that either indicates a rock. Now, a rock is when you like have your fist, right? You clench your fist. That represents a rock. Paper is just your outstretched and like the back of you just stretch your hand, right? Not like the palm, but people see the back. And then scissors is just so think of scissors like you want to shoot a gun. You know how we place our hands when we want to shoot a gun, but we'll separate our index index finger and the second one and the middle finger, right? So like a scissors, right? So those are the 3 hand gesture. Now, after that chant, right? Both players show that hand gesture, and it will be either that either indicates rock, a piece of paper, or a pair of scissors. Now, scissors beats paper. So this is how the game works. Scissors beats paper, paper beats rock, rock beats scissors. That's actually how it is. So if the 2 players come up with the same gesture, then that's a tie. Okay, so this is it. Scissors beats paper, paper beats rock. That's actually how it is. Scissors beats paper, paper beats rock, rock beats scissors. Okay, so let's build that. I think that's probably that's well just um That's where we'll just round up today's this thing on function. So let's create this game out. Let's call it rock, paper, scissors. Okay, so now, so one of the things, of course, we need to do, we need to be able to get a player move from the keyboard input, right? So we'll use our stdin.readline stuff, right? We're going to use it. So let's create a function that will return a string, because what we need is a string, right? I'll just call it get player move, right? So this is a function that will return what? A string. Okay, so let's just say, I'm going to do this quickly. Print would you like, so we need to, based on, because we need the user's input. So for rock, we'll use R to represent it. So this is just something like this. I'm just trying to pass it in a message kind of way. So P for paper, and then S for scissors, right? And then whatever, we want to now get the user's selection. Okay, so use our stdin, right? I'm going to import that. I'll just click enter and it will import it for me. Dot read line. Now I want to convert it to uppercase, right? So I want to convert the string, right, to what and what uppercase. So remember, I will have to make this nullable. Yeah, if I'm not, let's see, because so he said the method dot can't be unconditionally invoked. Like I'm making this, so we should use this to call it. Okay, so I think here is fine. Let's see. I could also, that's the thing about null. So maybe let's use this one. Yeah, okay. Now, so let's use a switch. We learned about switch and why we should use it. So I'll switch the selection. We just have three possible options. So we can just use switch, right? And then the first case, if it is an R that was chosen, what do we want to return? Remember, our function returns a string. So we'll return rock. Okay, so let me just duplicate this. Now, if it is a P, we'll return paper. If it is an S, we'll return scissors. Okay, and then so one thing we forgot to add is our break. I hope I getting that right. Let's see. It's telling me dead code. Okay, so hold on. Let me add a default. I don't know why it's telling me that, but let's just, so a default would be to return null. Oh, sorry, since we are returning a string, so let's just say quit. And so did I just add a curly brace? Sorry about that. And then we also need to break also. I don't know why, so it can't be reached. Okay. Well, I'll figure this. Let me see. Well, okay. You know what? Don't worry. I think I know what's up. But let me just run down this code. It's kind of a bit long. Now, so this actually should get the input of the user, right? This should get the input of the user. Now, we now need to, let's return a random move, right? Let's return a random move in the form of a string, right? So let's say we basically just want two players, right? So this will be computer. So get computer move, right? we want 2 players. That's where we'll actually get to enjoy this. So, but to be a random move, right? So let's create some random options, or you could say new random. So this is basically creating, and just for now, I wanted to say creating an instance, but we'll get to talk about classes and objects and all those. So we'll use our random dot next in. So we want to get a random number between 1 to 3. Okay, so I'm going to use a switch again, and I'm going to switch this my move. So we are using switch because we have a fixed number of distance. So in the first case, if it returns a 0, right, we'll return, let's say we'll return rock. Okay. So let me see. I still have this return code stuff. Okay, don't worry. So if the second case is 1, if it returns a 1, we return, let's return paper. And then if it returns 2, remember from a programming perspective, scissors. So we only need these options, right? We could now set up our default. In a situation where it doesn't give any of those things, it should just break. Okay, it should just break. So let me see something just to be sure. Okay, still doesn't want to. Okay, so break. So this is for the computer. Yeah. So I think I'm missing out something. And not just break. So let's return. Well, because we need to, and we can't return. I can only return null. For example, if I say, okay, fine, it's possible for this to be null, so I can just do this, right? I can just do that. We'll talk about null, but what I'm trying to say is that it's possible to actually have a null value. Okay, so let's just keep going now. The last function we'll create is to know who has won, right? Who has actually won this round? Who won? So let's say who won. We'll call it who won, right? Now first of all, we need to get to know who won. We need to get the player's move. We need to also get the computer move, right? Computer move. We need those 2 things to know who has actually won. So let's do a check. We can do an if here, and I'll check if the player move is the same as the computer move. So remember the rule, if both of them is the same, right? It actually means what? A tie. So return a tie. Remember, this is a string because this function returns a what? String. Another thing we'll check is else if player move. So if the player move, right, is rock, so that means the player actually chose rock, right? And the computer move is scissors. So what happens? So if player chooses rock and computer chooses scissors, it actually means that the player won. So we'll say return you win. Okay. So we also need to do some other check. So I'm just going to duplicate this else if. We need about 2 more conditions and then a final else. So okay, so I think I made Let's just keep this here. So this is this. This one is for this. Okay. Then this one is for this. Then this one is for this. Okay. So you can always align your code by just coming down here to click on format document. So the second condition is if the player's move is scissors. Let's look at this other condition. The player move is scissors and the computer move is paper, right? It actually means that the player has won. If the player chooses paper, right? And computer chooses rock. So let's also print you win. Else, which is a final else, that means none of these options actually were true. That means it's not a tie and you didn't win. So what does that mean? It actually means that the computer won. So we'll return a string because the function takes a return type of string. So computer wins. Okay, so this is it, right? So how do we now, so we now need to call these functions. Okay, we now need to call this function. So basically we'll need our main function because that's where execution starts from. So but I'm going to do it like, I'm going to use a while because I want to continue checking, right? I want to just do a game loop, right? So while true, I'll just pass through here. Print, let's just print rock, paper, scissors, shoot. Right? That's the call that's what you actually call before you start the game. So I'm now going to create a variable called player move, right? And it's just I'm going to assign. So I'm just going to store the word player move just by calling get player move. Remember, our get player move that's where it takes whatever the user actually types in, right? And it returns it. So what is being returned, I'm now storing it in this variable called player move. So let me just do a quick check. I'm just going to say if player move, right, is equal to quit. I'm just going to do this, right? So I'll return. So here I'm using an empty return, means that if this is not true, return. So it will just go out of this loop. This conditional to just escape it and continue whatever it was doing. And then let me say I want to print out what the user played. So I'm going to say you played. I'll use the same variable player move. Then I'm going to get computer move. Let me get computer move. Right? It's just going to return that to me. Now, because this is nullable, right? I'm just going to do this here. Don't worry, we'll talk about null, so don't sweat it. So I'm going to just print computer played. I'm going to call the computer move, so we know what the computer played. And then finally, I'm going to now print who won, right? Remember, who won returns a string. So I'll pass in the player move and then pass in computer move, right? Computer move. So this is just a null check. Okay, so let's see. Let's run and then let's see what we have. So you can see you have rock, paper, scissors, shoot. Would you like, so it's expecting from this get player move, it's expecting either an R, a P, an S. Anything apart from this means that it wants to mean that you want to quit. So we wrote a condition here that if the player move is quit, we should return. And how do we get quit? By not choosing either R, P, or S. So I'm just going to type T and click enter. So you can see what happens is this. So it just returns. So it's done. It just returns. So that means it will not run these other lines of code anymore, right? So let's run this again. And then this time I'm going to choose, so let me choose rock. So a capital letter. Well, I can do small letter or capital letter, but I'll use small letter because to test that, remember we said convert whatever text to uppercase. So I'll just use small letter to be sure. So when I click enter, you can see I chose R, which means I played rock. Computer played scissors, means I win. It comes again. So that's where this while that I used was this while loop. I'm already passing through, means that I want to be running this. So he told me again, would you like this? So let me choose rock. Let me choose rock again. Let's see if I'll win. I'll click enter. I win again. Computer played paper. Let me see if I can go on a winning streak and choose rock again. I played rock, computer played paper. Okay, computer actually wins rather. Oh, okay. So let me do scissors. Let me choose scissors. I played scissors, computer played scissors. You can see it's a tie, right? I'll play scissors again. I played scissors, computer, we are tying. I'll play scissors again. So it seems we are on a tie. We are still on a tie. Okay, so that's basically now functions, right? These are the basic things you need to know about what functions. So are there any questions? Are there any questions? If there are questions, please quickly raise your hand. I saw a message on the chat. Someone says, I can't install Dart in my laptop. I have only installed. Well, you take that to the Discord channel. Drop your challenge on the Discord channel. Okay, so that's basically that. Okay, this class actually was meant to be a short one. So that's just to introduce us to functions. Okay, now I'm going to drop something for us to work on. Right, on Thursday we're going to go into data structures. So Thursday is going to be a much longer class, right? We'll use the complete 2 hours and an extra 30 minutes if possible, right? So after Thursday, we'll talk about data structures on Thursday. And then by next week, we'll look into OOP. The whole of next week is going to be for object-oriented programming. And then by the upper week, we now start building. We'll get into Flutter proper, right? So I want to take my time to make sure that, we are grounded in these things. I don't want to rush in as much as I can, but it's not, I still know that I'll be able to cover what I need to cover in the time frame that we have. But at the same time, I need you guys to also push yourself. And one way I'm going to do that is by consciously leaving out some things and put it up for you to study yourself. And then when we come talk about it, right? This is not a university, right? This is tech. One of the things you need to learn in tech, I think somebody like Dele can tell you guys, is if you do not know how to pick up stuff on your own, if you do not know how to research for something on your own, if you don't know how to find solutions to problems on your own, then you will struggle in tech. That job you're looking for, that's nice gig you're looking for so badly, when it comes, it will actually show your inadequacy and you will struggle. You'll be taking 5 years to actually implement something. Why? Because you do not have the skill. See, searching for solution is a skill. It's something you actually have to pick up, you have to harness, right? So that being said, we're going to talk about 2 other things, but we'll talk about it on the Discord. I'm going to and then we'll talk about it tomorrow. So tomorrow we'll have a session, we'll have a class on Discord. Let me even put it that way. So we'll have a class session on Discord tomorrow, and it's going to just be us talking about stuff, right? I'll ask questions, you drop your answer, we'll explain. And what are we going to be talking about? So we'll just talk about still on functions, right? Still on functions. We're going to look at what we call optional parameters. right? Not just optional, positional optional parameters. So let me drop this on the chat. So I'll easily pick it up. And then we'll talk about named optional parameters, right? And then one very important thing, we'll look at the concept of, which you will look at actually, the concept of functions within functions. And then the last thing we'll talk about is recursive functions. Recursive functions. So these 4 things, let me drop it on the chat, but at the same time, I'll okay, so I'll drop down the Discord right now. So that's what we're going to look into. Okay, so any question before we shut down?
Hello, Moment. Hello.
Yeah.
Okay, please, Moment, I wanted to install that in my laptop, but it's not installing. If I click there, it's not showing anything. It will just be dormant.
Okay, see what will happen, right? Hold on. David, meet up with David on Discord. David will assist you. So go to Discord
Thank you.
now and just do @David Emeka. No, sorry, not David. Is it David? No, David or Ohimai. I think is that, yes, he should be the one now. Yes. Yes. Just mention him. So David, assist Cornelius. So 12 you should link up and then help him to install that. Right.
Thank you,
So
Moment.
Dele, you said you're getting unknown evaluation response type. So Dele, this is what you do. Send a screenshot of your code, of your function call. Send a screenshot on the chat. Right. Let's do that on the Discord. I want us to discuss today, tomorrow. We're going to our Discord channel will be busy. Right. So drop a screenshot there and then let's see what's up. Okay. So guys, thank you very much. Let's have a wonderful week ahead. Thank you.